Hello and welcome to my presentation on the BIM pilot project Dufourstrasse, which we could undertake on behalf of the Building Department of Canton of Zurich, Switzerland. To start, let me briefly introduce myself and our company, Equibridges. My name is Marcel Imbach. I'm a trained civil engineer and have been working as a project manager at Equibridges for more than 2 years, and as a member of the management team since this year. Through my work, I have gained a rich experience in the design and realization of large road and rail infrastructure projects. Equibridges is an engineering company specializing in bridge engineering and covers the full life cycle of a bridge, from design for new bridges, bridge preservation projects, up to strategic asset management of individual objects or whole road sections. Our topic today deals with the last two subjects. How can BIM be used in preservation projects and asset management? So let's look at the project. The bridge Dufourstrasse is located close to the city of Zurich, just at the southern border. There is a bridge crossing a larger road and railways. In fact, there are two, or when you look closely, there are even three bridges in this area. The full infrastructure object is named as the bridge Dufourstrasse, and it also covers a pedestrian underpass, retaining walls, stairs and ramps to access the bus stop on top of this bridge. We focus in this BIM pilot project on the abutment area on the eastern side. The bridge itself is managed by the Building Department of the Canton of Zurich. The bridge was built in the 17th and is today more than 55 years old. There was a refurbishment campaign in the year 2000, which mainly focused on the bridge structures, so the abutment section is mostly untouched. The abutment itself is geometrically complex, with many single elements, many joints, stairs and ramps. You see here some images. When you look closely, you can clearly see the ongoing aging process. The bridge are connected to the abutment, so there is a fixed abutment here. You also see here the two main bridges and the smaller third one bridge for pedestrians. There are local damages, typically water ingress at joints, and also some local spalling or cracking. The process of bridge preservation is well known, and I don't want to focus on explaining these steps in this presentation. The project itself has the following objective. How can this process of preservation be done using BIM? How can the information from maintenance on damages, condition assessment and structural analysis be incorporated into BIM? How can a smooth handover of labor be ensured? What are available tools and what attributes are necessary for a successful implementation? The BIM pilot project Dufourstrasse is likely one of Switzerland's first projects to specifically address these questions. So let's take a look at the outcome of these questions directly in the BIM model of Dufourstrasse. The project focus on this rather complex abutment area. So you see now 3D model. You can clearly see the various different elements, and you will immediately recognize the first benefit of BIM, namely 3D planning. So without detailed knowledge of BIM, you quickly gain a good overview of the structure, This is an important advantage because infrastructure decision makers oversee many different structures and they only spend a limited time on each. The full model was created based on construction drawings from the 17th, namely formwork and reinforcement plans. Navigating through the 2D plans was not always easy because often reference axes were missing or lost. So using Allplan BIM Plus helps very well navigating the model. So we prepared slides to ensure that everyone sees the same and that also less experienced individuals can navigate the model easily. You can easily move sections to get a better understanding of the structure. So you have seen here this rainwater tank below the abutment. So this is the bridge abutment. You see here one bridge coming in. Also here, now you see the full section with characteristic T-beams of those rainwater tank. So the abutment of the bridge is fixed on top another existing structure. So the representation in Allplan BIM Plus is really good, a good tool, and it helps to navigate the model. All those elements are attributed. Also with transparency, you can easily highlight some interesting characteristics like those tendons. And of course, if you attribute them, you get all the necessary information. The attributes are defined by client specification. And the building department of Canton of Zurich has there a leading role in Switzerland. They understand very well that the uniform attributes across objects and project stages are critical for a successful BIM implementation. Only in this way, BIM can attribute to a smart asset management. One goal of this project was also to better understand which attributes are relevant for asset management of existing structures. They do not necessarily be the same as for new construction, as the focus is different. Today, asset management happens with databases, and the goal is to integrate or sync this BIM model into these existing platforms. Now, managing infrastructure is more complex than it can be just done with attributes. Geometry and basic attributes are only one part of our model. We also have further information, inspection results, damage reports, results from condition assessment, structural analysis, etc., which we should integrate into our BIM model. We represented those models in individual discipline models, which we called them submodels. Goal is to get a smooth knowledge transfer over phases, so that the next engineering office don't start from zero without any loss of information. In our damage model, different color represents different damage types. E.g., damage of pathways is here purple. Structural damage of concrete, say from water ingress, is red. Or just cracking is orange. We also report equipment damage, like for lightning or damaged doors in purple. Using filters in Allplan BIM Plus, you can display only the relevant damages, and also with transparency, you get a good overview. Also with those slides, pre-prepared slides, you can easily navigate the model. And also the damages, they are attributed, and you can also get attachments like photos to each damage. Each damage has a unique number, so the photos are referred also to each damage. So you see here typical damage of structure, and with the 3D you get a good understanding on where those damages are. Are they top down or bottom up? And also you see how those damages are connected with complex geometry. So we did this damage model quite schematic because it's a great tool in helping to get an understanding of where the hotspots of damage of the agenting process happens. And it's not a representation of the reality. You can also overlay information, typically also from condition assessment, and so you get good and easy understanding of what have been done and where. Comparing this 3D model to the methods using currently for existing structures, you can easily see the advantages of using BIM and the 3D model. So understanding such a 2D drawing is not easy, but it's the common way today. Also, regarding condition assessment, various material tests were conducted in this project. In this case, a potential field measurements of the ceiling has been executed, and you can see the result or then the interpretation directly in the BIM. Also here, you get the results directly attributed, and also when clicking on samples from material testing, you get the relevant attributes directly in the model. Due to the lack of reinforcement plans, reinforcement was determined using radar and then shown in this model. So the next engineer will find this data directly in the model, so he understands where those results are coming from. We put there some attachments from the report so that you don't have to look up into the former report. Of course, the reference is there. A strength of BIM is its machine-readable data handling. So this allows us to filter the functions to display relevant results. So here you can also see GeoRadar, GPR measurements we have executed on both floors, one on top at the bus stop, one beneath in the pedestrian underpass to identify possible wet spots and also to check the difference between the existing surface and the level according to the plan. So we could also measure the thickness of those slabs. So finally, also with transparency, you get a good understanding on what have been executed where. Also here you can use different colors for different sample testings, and of course those attributes should be common, should be the same for all those projects the Canton of Zurich is handling. We believe that results from the structural assessment should also be documented in BIM. If the structural assessment is only stored on paper, much of its utility is lost because the most important results from the structural assessment, like utilization rates, associated load patterns, the structural model boundary condition, etc., can be represented as attributes or elements directly in BIM. So you get a good understanding about the structural model. In this case, you can see that the sidewall of the pedestrian underpass contributes essentially to the load transfer of the bridge abutment. And also we can highlight hotspots like where is pre-stressed cables going, what are other insights like do we have water tightening, waterproofing, so we can guide the next inspection and prepare the inspection in the office with our 3D model. Finally, we also present our recommendation in a submodel. All those models will be transmitted to the next engineer, who will then design the refurbishment project based on all those information. We think this is an advantage of BIM over the current state, as this new project designer has not to study and think into all those reports and analyze these reports deeply. So he can start with detailing the solution at the right spot right away. So some final thoughts. The BIM pilot project Dufourstrasse has shown the possibilities using BIM for managing rather complex existing infrastructure. Interdisciplinary is a strength of BIM. Goal of using BIM is to reduce or eliminate information loss also during years of one building. Also, future technologies can help in speed up the process, like LiDAR or augmented reality can be integrated into BIM. For example, using LiDAR, you can get rid of photos and managing photos, putting photos together. It's a very interactive way to understand the current or past condition of a structure, and of course, it's like a photography, so engineering judgment and interpretation of the results is still necessary. So with that, I finish this presentation. I think we should not only focus on think of BIM for new construction, but especially for managing existing infrastructure. BIM should provide benefits to operators, and the infrastructure owner should benefit from BIM because it allows for a more efficient work. We hope that the BIM pilot project Dufourstrasse has contributed to this goal. Many thanks to the building department of Canton of Zurich for initiating this project and all those other partners working on it. Dear viewers, thank you also for your attention. I hope I provided some informative insight and wish you a great and educational Allplan Infrastructure event 2024.